Welcome. This video will explore point-to-point communication links and their function in providing access to the WAN. WAN communication involves the first two layers of the OSI model. At layer 1, we will examine the advantages of serial communication over parallel communication. At the data link layer, we will introduce two WAN protocols, High-Level Data Link Control Protocol, or HDLC, and Point-to-Point Protocol, or PPP. It is important to know the information in this video because many businesses use point-to-point WAN links and their respective protocols for site-to-site connectivity. Long-haul communication and most computer networks use serial connections rather than parallel connections. This is because of cable cost and synchronization difficulties associated with parallel communications. Serial cables can be much longer than parallel cables because there is less crosstalk among the conductors in the cable. Looking at this simple representation of a serial connection, notice the data is encapsulated by the Layer 2 protocol used by the sending router. The encapsulated frame is sent on a physical medium to the WAN. There are various ways to traverse the WAN, but the receiving router uses the same Layer 2 protocol to decapsulate the frame when it arrives. On each WAN connection, data is encapsulated into frames before crossing the WAN link. The choice of Layer 2 protocol depends on the WAN technology and the communicating equipment. This graphic shows the most common WAN protocols and whether they are leased lines, circuit-switched, or packet-switched technologies. The two WAN protocols we will examine are HDLC and PPP. Cisco HDLC is the default encapsulation type on point-to-point connections, dedicated links, and circuit-switched connections when the link uses two Cisco devices. Cisco HDLC has the added value of its capability to support multiple protocols, whereas standard HDLC supports only single protocol environments. HDLC uses synchronous serial transmission to provide error-free communication between two points. HDLC defines a Layer 2 framing structure that enables flow control and error control. Although there are multiple types of frames, each frame has the same format, whether it is a data frame or a control frame. You can study the frame fields in more detail on your own so you can fully appreciate how much information HDLC transmits to provide WAN communication. As mentioned, Cisco HDLC works only when using Cisco devices on each end. In fact, if you have Cisco routers at each end, no configuration of HDLC is necessary. That's not to say you don't need to understand how to troubleshoot HDLC, but the actual configuration is simple. If connecting to a non-Cisco router, point-to-point protocol encapsulation is an excellent choice. Point-to-point protocol has been designed to retain compatibility with commonly used hardware. PPP is a flexible protocol because it can establish a direct connection using serial cables, phone lines, trunk lines, cellular telephones, specialized radio links, or fiber optic links. Other advantages of PPP include its non-proprietary nature and features not available in HDLC such as link quality management and two methods of authentication. Let's look at how a PPP session is established. Point-to-point protocol uses a link control protocol or LCP for establishing, configuring, and testing the data link connection. The LCP also negotiates and sets up control options on the WAN data link, which are eventually handled by network control protocols or NCPs. With the help of NCPs, PPP permits multiple network layer protocols to operate on the same communications link. This graphic shows the full link establishment, maintenance, and termination processes. This is obviously a complex process, but the point is that the LCP is in charge of establishment, maintenance, and termination of links. This is accomplished through the dialogues between the sender and receiver's respective LCPs. For every network layer protocol being used, point-to-point protocol uses a separate NCP. After the LCP has configured and authenticated the basic link, the appropriate NCP is invoked to complete the specific configuration of the network layer protocol being used. For example, if both IP and IPX are being transmitted, LCP sets up a communication link for each protocol. Point-to-point protocol enables negotiation of an authentication protocol between peers before allowing network layer protocols to transmit data over the link. There are two authentication protocols used by point-to-point protocol: Password Authentication Protocol, or PAP, and Challenge Handshake Authentication Protocol, or CHAP. As a network engineer, you need to know the difference between the two and how to configure them. PAP is a very basic two-way process. No encryption is used, so the username and password are sent in plain text. If accepted, the connection is allowed and authentication is never verified again. This leaves the network vulnerable to attack. CHAP is more secure than PAP. It involves a three-way exchange of a shared secret, and it conducts periodic challenges to make sure that the remote node still has a valid password. Point-to-point protocol can also be configured to use compression and load balancing. While we cannot cover all the details in this video, network engineers need to know how to configure these options to provide a secure and optimized WAN connection. Your ability to configure point-to-point serial connections is central to creating WAN connectivity for enterprise networks. Both HDLC and PPP are simple WAN protocols to implement. Nonetheless, you should practice in a lab environment to develop superior skills with these two basic protocols.